So here's the first example. So my first step is to find and name the longest parent chain. So if I look at this, I could go 1, 2, 3, 4, but it's probably best to go 1, 2, 3, 4, 5. So I have a 5 carbon parent chain as my main chain. So that means this whole molecule would be called pentane. Then I need to decide how I'm going to number it. I could number it from left to right, so 1, 2, 3, 4, 5, or I could number it from right to left, where I'd go 1, 2, 3, 4, 5. But the rule is you want to start numbering closest to the side chain. So I would number this 1, 2, 3, 4, 5. Once I've done that, I then need to figure out what my side chains are. So on my second carbon, I have a methyl side chain. And on my third carbon, I have another methyl side chain. And I'm naming these methyl because they're both just single carbons attached to my side chain. So I have a 2-methyl and a 3-methyl. So what I need to do is I would group these together to become 2,3-dimethyl. And so it's a 2 and a 3 because that's where they're located. Di is saying that there are 2 methyls. So you have to have a prefix for how many you have if it's over 1. Then all I need to do is take this and this. So the side chains and the parent chain combined in one name. And the parent chain always comes last. So this molecule's name would be 2,3-dimethylpentane. Okay, let's look at a second example, and this one's a little bit more complicated. So my first thing I would need to do is find the longest chain of continuous carbons. So 1, 2, 3, 4, 5, 6. Well, this molecule's pretty big, so maybe there's a longer one. I could go 1, 2, 3, 4, 5, 6, 7. That's pretty long. Remember, the longest chain of carbons does not have to be straight. I could also go 1, 2, 3, 4, 5, 6, 7, 8. And I think that's the longest this molecule will get for a carbon chain. So that means my longest chain of continuous carbons is 8. So the parent chain would be named octane. Oct for 8 carbons, and ane because they are all bonded in single bonds. Then I need to decide how I'm going to number this. So would I start here and go 1, 2, 3, 4, or would I start here and go 1, 2, 3, 4? Now, remember the rule is to start numbering closest to the side chains. So I would number 1, 2, and there would be a side chain here. If I started numbering from this side, it would be 1, 2, 3, 4, and there wouldn't be a side chain till 4. So I would start numbering at the top right here and then number up to 8. So 1, 2, 3, 4, 5, 6, 7, 8. My next step is then to take and find the side groups, name them, and number them. So this would be a side group on the second carbon. It's a methyl group. On the third carbon, there's another methyl group. And that's for the one below. On the 5th carbon, there is a 2-carbon side chain. So that would be monkeys eat. So F, ethyl side group. So these are my side groups. 2-methyl, 3-methyl, and 5-ethyl. Now once I have all this information, all I'm doing is taking it and combining it into one name. So what comes first are the side chains, and I name them alphabetically. So what would come first is 5-ethyl. Oh geez, sorry, pardon my writing. That's really bad. 5-ethyl, because E comes before M alphabetically. Then I would combine these to be a 2, 3, again a dimethyl because there are 2 of them, 2,3-dimethyl. and the parent chain comes last. So that would be the name. 5-ethyl 2,3-dimethyl octane. Okay, so hopefully that makes a little bit of sense. You have this YT1, so you try one. There's 3 examples there. I would get you to pause this video right now and either individually or at your tables see if you can figure out the names for those 3 molecules that I have in your work booklet. So hopefully pause the video and try these out. I'm going to go through and name them now and explain my rationale for naming them. So here is the molecule. It's 1, 2, 3, 4, 5, 6. I'm looking for the longest carbon chain. Or I could go 1, 2, 3, 4, 5, 6. Doesn't really matter, but I'm going to prefer to look at this as a straight chain. So that means I'd have a 1, 2, 3. It's a 6 carbon, so it's hexane. Hex because it's 6 carbons, and ane because they're all joined in single bonds. And then I would want to number this, so I could either number from left to right or from left to right or from right to left. If I number this way, this would be on the 3rd carbon, so that's what I'd want to do. 1, 2, 3. So on the 3rd carbon, there is a 2 carbon side chain, so I would name that 3. 2 carbons is a eth, so ethyl. Ooh, that's bad. So the whole name for this would be 3-ethyl hexane. Then the next one. And so this is that line structural formula where technically you have a carbon at all of these locations. And when I'm doing it, I sometimes like to draw it on there just so I can kind of see where the carbons are. So same process as before. My first step is to look for the longest chain of continuous carbons. So if I start like here, it's 1, 2, 3, 4, 5, 6. It's pretty long. 1, 2, 3, 4, 5, 6. And I don't think it's going to get any longer than that. So again, I'm just going to take this as my main chain, or my parent chain. So that would mean, again, I have a hexane as my parent chain. Then I would figure out where I want to number it from left to right. So that would mean I'd have a side group at 1, 2, 3, 4, 5, or 6. If I went the other way, I wouldn't have the side chain until 3, so I'd want to number it from left to right in this case. So from there, I need to figure out what my side groups are. So I have a 2 side group at methyl, so 2-methyl. Oh my goodness, I'm so sorry. That's really bad. A 2-methyl, a 3-ethyl, and another 4-methyl. So once you have all of this information, you just need to take it, put the side groups in alphabetical order, and the parent chain comes last. So I would have a 3-ethyl first, 2,4-methyl come together to give me a 2,4-dimethyl. Stop it, Rhaegar. Dimethyl. So that's gone. Oops. And then hexane would come last. So 2,4. Stupid thing hates me. So 2,4-dimethyl 3-ethyl hexane should be the name of that molecule. Okay, and then your last example for you to try. Pretty complicated here. So first thing to do is find that main chain hydrocarbon. So I'm going to guess 1, 2, 3, 4, 5, 6, 7, 8. That's pretty long. 1, 2, 3, 4, 5, 6, 7, not nearly as long. 1, 2, 3, 4, 5, 6, 7, 8. That would work too. I'm gonna go with this as my main chain hydrocarbon. Okay, so this is a 1, 2, 3, 4, 5, 6, 7, 8. So it's an 8 chain parent chain. So we would call this octane. Oct for 8 carbons and ane because they're all single bonded. Then I need to number this. So I would number it starting from here because I go 1, 2, 3, and that's where a side chain would begin. Here I would go 1, 2, 3, 4, and that was where it would begin. So this would be 1, 2, 3, 4, 5, blah, 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 6. So from there I need to figure out what my side chains are. So on the 3rd carbon, I have a 2 carbon side chain attached, so that would be a 3-ethyl. As well, on the 3rd carbon of my parent chain, I have a 3-methyl attached. On the 4th carbon of the parent chain, I have a 3 carbon side chain, so I would call that 4 monkeys eat peeled, so propyl. And there's another 3 carbon side chain on the 5th carbon of my parent chain, so I would call that 5 propyl. So now that I have all of my pieces of information, the parent chain and the side chain, all I would do is take all of these and combine them. So first come the side chains in alphabetical order. So it would be 3-ethyl, 3-methyl. These two would combine to give me a 4,5-dipropyl. You have to give the prefix for however many side chains there were. So 3-ethyl, 3-methyl, 4,5-dipropyl, and then the parent chain comes last as octane. So hopefully you were able to get that. Okay, I was going to do drawing alkanes, but I think what I will do is just get you guys to take a look at the homework. I believe it's on page 370, numbers 7 to 10. If it's asking you to draw the alkanes, you can try. It's just the reverse process, but we will go through that in a little bit more detail tomorrow. So page 377 to 10, whatever ones are asking you to name the alkanes, not draw them. Okay, thanks guys, I'll see you tomorrow.